Okay, lesson 2, example 5. When electrons transition from an excited state to the ground state of Mercury, a 256 nanometer photon is released. What is the energy of Mercury's ground state? So if we look at the diagram here, we can see that the n equals 2 energy level for Mercury is negative 5.52 electron volts. So what we're going to do is we're going to calculate the energy of the photon. Here, because we're being given a wavelength, we're going to use hc over the wavelength. And because over here, one of the energies is being given in electron volts, where we see h, we'll use the electron volts version. So 4.14 times 10 to the negative 15 electron volts seconds times the speed of light, which is 3 times 10 to the 8 meters per second, divided by the wavelength. Make sure that the wavelength is in meters, not nanometers. So we'll write this as 256 times 10 to the negative 9 meters. So calculating that, we find that the energy of the photon that is released because the electron made a transition is about 4.85 electron volts. So now what we need to do is we need to figure out what this question mark is. So we need to figure out what the energy associated with the first energy level is. So we're going to write down what the change in energy for the electron that's making the transition is. If the electron is going up to a higher energy level, then its change in energy will be positive. But if the electron is going from a higher level to a lower level, then the change in energy will be negative, because that negative signifies that it's losing energy. So remember that the energy of the photon is always equal to the change in the energy for the electron, but you have to put a negative in front here if it is losing energy, which here the electron is losing energy because it's falling down to a lower energy level. So the change in energy for the electron is the final energy minus the initial energy. Final energy is always the energy that you end up at. So because here the electron started at level 2, the energy of level 2 is going to be the initial energy, and it ended up at level 1, so the energy of level 1 is going to be the final energy. So here we're looking for the final energy. So what we'll do is we'll write it like this. Change in energy for the electron plus the initial energy is equal to the final energy. So the change in energy for the electron, that was negative 4.85 electron volts. And the initial energy was negative 5.52 electron volts. So we're adding to this negative 5.52. Whatever that is the final energy of the electron. So I get, just a second. Okay, so I get negative 10.37 eV as the final energy. So the final energy is going to be the energy of energy level 1. So energy of the first energy level here to 3 significant digits is going to be negative 10.4 electron volts. Now, one thing that you always want to check, just to make sure that you haven't messed up a negative somewhere, okay, if we have our two energy levels, so this is n equals 1, and this is n equals 2, n equals 2 was at negative 5.52, okay, as we go up to higher energy levels, so as we go up this way, our energy levels should be getting closer to 0. So just double check that that's correct. So negative 10.4 We go up, we get negative 5.52. Negative 5 is closer to 0 than negative 10, so that means that we've done this question properly.